Okay, now to begin our actual look at absolute value equations. Absolute value is the distance from zero. It is indicated by this symbol right here on either side of your number. So the absolute value of 2 is equal to something, and the absolute value of negative 2 is equal to something. So let's look at a number line to help us understand this. Okay, there's my number line. If I want a number that is 2 units from 0, well, 2 units from 0 would be this much, and this is one number. So that number 2 is 2 units from 0. I also have another number that is 2 units from 0, and that number is the negative 2. Okay? The 2, the positive number up here, tells you the distance this number is from 0, and the distance this number is from 0. The positive and the negative tell you the position on the number line. You see, if we were to measure something and you wanted to measure it, if you have 0, you don't have anything to measure. If you have something to measure, it has to be positive because it has to have something there, and you can't measure negative because negative means that you have less than nothing. So if you have nothing to measure, you can't measure it. And so therefore, this is why distance is always positive. And so it's really important to understand that. And so we have 2 units from 0 in this case. So my absolute value of my 2 is 2. My absolute value of my negative 2 is also 2 because both of them are 2 units from 0. If I ask myself, what is the absolute value of x equal to, and I say my number is 2, this is asking me what are the numbers that are 2 units from 0. So x is equal to the positive 2, or x is equal to the negative 2 because a negative 2 is 2 units from 0 and a positive 2 is 2 units from 0. Okay? Any questions? This is important to grasp. The absolute value is positive because it's the distance from 0. The negative and positive numbers tell you the position that number is in relationship to 0. So it's important to grasp that difference. Okay, before we go into actually solving absolute value equations, let's first of all look at simplifying some of them, some of the expressions. Just like we started with the other equations, we did expressions first. Okay, 4 minus 6 is equal to a negative 2. Notice you do what is inside before you do your absolute value. So 4 minus 6 is a negative 2, and it's still inside the absolute value marks. And the absolute value of negative 2 is 2 because it is 2 units from 0. Even though it's on the number itself is on the negative side of 0, its distance from 0 is 2 units. Okay, let's look at another one. Okay, again, what's inside? 3 times 3 is 9, minus 4 gives me an absolute value of 5, which equals 5. Okay, so we simplify it down, multiplication, then our subtraction, and notice it doesn't come out of the absolute value until the very end. Let's do one more. Okay, 3 times negative 4 is a negative 12 minus 2, and that's equal to a negative 14. Out of the absolute value marks gives you a positive 14 because it is 14 from 0. So now let's look more at actually solving absolute value equations. Okay, one thing to note, let's do one of them and then we'll note something. The absolute value of x is equal to 4. This is asking me what 2 numbers are 4 units from 0. Thus, x is equal to a positive 4 or x is equal to a negative 4, because the absolute value of 4 is equal to 4 and the absolute value of negative 4 is also equal to 4. Notice they are in agreement with your answer on your equation. Therefore, we know we have the right answer. So how many answers did my absolute value equation give? It gave 2 answers. And that's an important thing to remember about absolute value equations. So remember, we're looking at distance from 0, if we're doing a expression, you're going to use PEMDAS inside. To simplify inside before applying the absolute value. Okay? What else is true about those equations? The inside of the absolute value is equal to both a positive and a negative. Did you see that? The inside was equal to both a positive and a negative. And that gives me, in most cases, there will be 2 answers. Okay? But not in all cases. Let's look at an exception to the rule. The absolute value of x is equal to 0. Is 0 positive and negative? 0 is neutral. You have 1 0. You don't have a positive 0 and a negative 0. So therefore, if the absolute value of x is equal to 0, you have 1 answer. So that's one exception. Okay. Let's look at another possible exception here. Now, I have the absolute value of x is equal to a negative 2. What's my problem? I have just said that the distance from 0 is a negative 2. Can distance be negative? No, it cannot. Therefore, this is not possible. And because it is not possible, there is no solution. Okay, so you have most of the time 2 answers, equal to 0, 1 answer, equal to a negative number is not possible, or no solution, or no answer. And we can use that 0 with a line drawn through it, okay? So now let's look at some examples of solving these equations. We're going to start with the simplest and then get harder. Okay, we've already done the very simplest, but let's do one more. The absolute value of some number is equal to 9. Therefore, x is equal to a positive 9 or x is equal to a negative 9, because 9 is 9 units from 0 and negative 9 is also 9 units from 0. Okay? How about this one? The absolute value of x plus 9 is equal to 5. We're looking for this expression to be equal to either a positive 5 or a negative 5. Because remember, this is equal to 5, the absolute value of 5 is 5, and the absolute value of negative 5 is also 5. So therefore, this expression inside here can either equal a positive 5 or it can equal a negative 5. So we have two equations which gives us two answers. So we have x plus 9 is equal to 5, or x plus 9 is equal to a negative 5. Subtract our 9, just like equation solving that you've done in the last assignment, and 5 minus 9 is a negative 4. So that's one of my answers. Subtract my 9 again, and x is equal to a negative 14. There's my other answer. Now let's check it. Let's put it back inside and see what happens. Negative 4 plus 9, that's equal to a 5, which gives me a 5, which is the same as what I started with. Now let's try the other one. Negative 14 plus 9 is equal to a negative 5, which is also equal to that 5 being 5 from 0. So this 5 also agrees with that 5. So we know we got the two correct answers. Let's look at another one that is fairly simple like that. Gotta put back in. I don't hold it on to it, it goes and falls off the little hook. Okay. Let's do one with the minus in there. X minus 2 is equal to 11. Okay, remember, this thing inside here can either equal that positive 11 because the absolute value of 11 will equal 11, or it can equal a negative 11 because the absolute value of a negative 11 equals 11. You don't need to show this part. I'm just showing you why it is, okay? So, by x plus 2, not plus 2, x minus 2, let's read the right problem. X minus 2 equals 11, or x minus 2 equals negative 11. Notice this part doesn't change. It stays the same for both of them. Now I'm going to add my 2 to eliminate it. That's going to give me x is equal to 13. Same thing over here. And I end up with x is equal to a negative 9, because negative 11 plus 2 is a negative 9. There's my two answers. I can check it. 13 minus 2 is 11. Absolute value of 11 is 11. Negative 9 minus 2 is a negative 11. And the absolute value of a negative 11 is 11. So it's a true statement. Okay? Now let's look at another one. Okay. Negative x minus 3 equals 8. Okay, remember, the stuff that is inside and it doesn't change is either equal to my positive 8 or it is equal to the negative 8. And notice what's inside is written the same both times. Now we solve. Add the 3. And I get a negative x is equal to an 11. Now divide by that negative 1, which is invisible, and it gives you x is equal to a negative 11. Notice you can have negative answers, but we can't have a negative up here, so we have to keep that distinction, that difference going on. Negative x minus 3 equals negative 8. Add my 3. and I end up with negative x is equal to a negative 5, divide by the negative 1, and I end up with x is equal to a positive 5. Okay? So, we don't always end up with a negative and a positive answer. So far we have, but that's not always going to be the case. So there you are. We've done several problems of that type. Now let's do another one. Okay, now remember what we said over here? Absolute value equal to 0. You have one possibility because 0 is not positive and negative, it is only positive, and therefore you cannot have a negative number. So therefore all we can do is take what is inside, put it equal to 0, and then go on and solve. Notice I don't solve from here, I solve from here. Because as long as those absolute value marks are there, it is like a barrier, it is like a bar that stops you from being able to do anything. So you have to bring it out before you can work with what's inside. And so we have 2x equals 3, divide by 2, and my x is equal to 3 halves. Okay? A fraction. Leave it just like that. It won't simplify anymore. Just leave it like it is. Notice, when it's equal to 0, there's one answer. When it's equal to a positive number, like we've done already, there's two answers. Okay, how about this one? X plus 5 equals a negative 12. What's my problem? Again, remember, absolute value has to equal a positive number because it has to equal that distance from 0. I have my absolute value here. I'm saying it's equal to a negative number. Is that possible? No, it's not, because negative is not a measure of distance. Therefore, this one has no solution. Whenever you have an absolute value, or you can write it like that, whenever you have an absolute value equal to a negative number, stop. Ask yourself, what's going on here? Remember, absolute value is a measurement of distance. Therefore, if I have an absolute value equal to a negative number, I'm in trouble. I can't really do anything with it. And therefore, I have no solution, because even if I go on and try to solve it and then put those numbers in to check it, it's not going to work out. It's going to give me a no answer. So it's really, really important that when you have it equal to a negative number, that you recognize that it is not possible to do that. I often say stop, look, think before you act. Okay? Stop, look at it and think, reflect on it. Is this possible? Before you act. Whenever in math we get into the habit of just chunking it through according to a pattern of process that we've been doing, we'll get in trouble eventually, because we're going to run into something like this that is going to demand that you stop and think before you do it. Okay? So, now let's look at another type. Now, notice that on this one we have an absolute value plus some number equal to another number. Now let me ask you, which part of this side of the equation has two possible solutions? Is it the whole thing like that? Or is it just the absolute value part that gives you your two solutions? If you think about it, it's only the absolute value part, because it's the stuff inside that has that two possibilities, right? Yeah, it is right. So therefore, before we can deal with our absolute value, it must be isolated, just like here, when you were solving for x, you had to isolate the term with the x before you could go on and solve. It's the same kind of principle. We have to isolate our absolute value first. So, the first thing we're going to do is eliminate what has been added to it that is outside the absolute value, leaving my absolute value of x is equal to a 4. Please do not skip this step. A lot of you will want to skip this step, and you'll start here. You'll write this whole thing equal to 12 and equal to a negative 12, which isn't possible, because it is not, this 8 isn't inside the absolute value. Therefore, it can't have two possible solutions at that point. It's here that you have two possible solutions of x equal 4 or x is equal to your negative 4. Because x is all alone inside there, there's not much to do once you isolate it. So you've got to isolate that absolute value first. So now let's look at another one. Minus 5 equals 7. Okay, again, this is the only part that's inside that has two possibilities. So therefore, the first thing that has to happen is the isolation of that whole expression. So we're going to add 5 to both sides in order to eliminate it. And we're still left with absolute value of 2x plus 3 is now equal to the number 12. We're still good. We got a positive number here, so we can still roll on. Now, this inside is either equal to that exact number, or it is equal to the opposite of that number, which is your negative 12. Okay? Now, go ahead and solve. Subtract our 3 first to eliminate it, leaving 2x is equal to 9 divided by 2, and I have x is equal to 9 halves. Now, same thing here, minus 3. And notice your numbers are nowhere near the same. And now divide by 2. So x is equal to a negative 15 halves. Okay. Any questions so far? Almost done with this one. Got 2 more examples to do. Okay, what's my problem? I have an absolute value equal to a negative number. Can you have a negative distance? No. Therefore, this one is a no solution. Remember that this absolute value, if I stick numbers in, it's always going to produce a positive. A positive is not equal to a negative. Therefore, it's not possible and it's no solution. Okay, let's look at one more. So far it looks good. I've got a positive number over here, but this isn't isolated yet. So therefore, when I subtract my 10 from both sides, what happens? I still end up with my absolute value is still there, and it's equal to 5 minus 10 is a negative 5. Now, I'm in the same problem I was in the previous problem. I have an absolute value equal to a negative number, which is a positive equal to a negative? No, that's false. It's not possible. So therefore, there is no solution. Okay? You are now ready to do your absolute value worksheet. Have fun!